Hi, and welcome back. So let's try out another one of these Chem final exam prep problems. So here's the problem. What is the de Broglie wavelength of a 2,945 pound car driving on the highway at 67.0 miles per hour? So that's, it's more or less somewhat of a straightforward problem, but here's sort of the kicker, and this is I actually had an exam question that this was more or less the same kicker on it, I guess, or the same thing about it, was that these were the only conversion factors I got. I got 1 inch is equal to 2.54 centimeters, and 1 pound is equal to 453.592 grams. So based on that information, we should be able to figure this out completely. So if you want to pause the video now, and hopefully now you've unpaused the video because I'm going to start working through this. So the very first thing to remember is just what is the de Broglie equation for wavelength. It's going to be our wavelength, so lambda, is going to be equal to Planck's constant h divided by our mass times our velocity. And remember, this is sort of one of the maybe slightly confusing things, but remember our mass for this equation is always going to be in kilograms, and our velocity is always going to be in meters per second. So therefore, it's sort of maybe, hopefully you can see that we're going to have to convert these units. We've got 2,000 or 2,945 pounds. That has to get converted into kilograms. We've got 67.0 miles per hour. That has to get converted into meters per second. So, and we've got some, maybe you might think some challenging conversion factors. So anyway, let's start with this 67.0 miles per hour. So let's set up our conversion factor, and we say that we have 67.0 miles that we travel in every 1 hour. So that's our first factor, and that's what we're trying to convert. So let's start first off. We're going to convert our distance. And actually, you know what? I'm actually going to maybe shrink this. Actually, you know what? Here, I'll actually just do this like this. So we're going to start on our distance. So first thing we're going to do is we're going to convert miles. We're going to say 1 mile. And this is something that, particularly if you live in the United States, this is a good number to have in the back of your head, that 1 mile is equal to 5,280 feet. And if you're in Denver, you should never forget that number. That's Denver's elevation is 5,280. So 1 mile is 5,280 feet. And then we have to get inches, right? Or that's what our conversion is. We're converting inches into centimeters, so we have to get down to inches. So we can say 1 foot is going to be equal to 12 inches. And then from here, 1 inch is equal to 2.54 centimeters. So 1 inch is going to be equal to 2.54 centimeters. So now we're in metric, and this is maybe a little bit easier to convert. I'll keep going. I'll start a new line down here. So now we can keep going, and we can say 2.54, or we can say that, let's convert centimeters into meters. So we can say that 100 centimeters, so we want centimeters to cancel out, is going to be equal to 1 meter. And actually, you know what? I am going to move that back. Let me see if this actually works. Hey, it actually did work. Well, it kind of worked. It's still off the page. Actually, you know what? Sorry, I'm going to waste your time. Sorry about that. I'm actually not going to do that. So now, anyway, the important thing to realize right now is that we've converted all of the distance. We've converted all of the measurements of length. But now what do we have to do? We have to do the same thing for time, right? Because what do we have right now? If we were to cancel out all of our units, miles with miles, feet with feet, inches with inches, centimeters with centimeters, we would be left with meters per hour, right? So now we have to work on converting these hours into seconds, right? So now we're going to multiply this, and we're just going to say, we're going to try to turn hours into seconds. So we want hours to cancel out. So we say that 1 hour is going to be equal to 60 minutes. And then we want minutes to cancel, and we want to be left with seconds. So we say that 1 minute is equal to 60 seconds. And then that's it. We've converted everything. After we do all of this operation, we're going to be left with this velocity. We've got 67.0 miles per hour. And when we do all of this, we're going to have meters per second. So actually, I'm going to go ahead and get out my calculator. Okay, there we go. So I'll probably be covering... Actually, there we go. That's perfect. Okay, so we start off with 67, multiply that by 5280, multiply that by 12, multiply that by 2.54, divide by 100, divide by 60, and then divide by 60 again. And we are left with 29.95, and let's say let's say we're left with 29.952. So we're going to say 29.952 meters per second. So this is going to be our velocity, right? That's where this fits into the equation. So we've now figured out our velocity. Now let's work on our mass. So we have this mass that's in pounds that we have to get into kilograms so we can stick it into our equation. So actually I'm going to move up here. There we go. So we can see everything. So we start out with saying we have got 2,945 pounds. And we're saying 1 pound is equal to 453 grams. So we say that 1 pound, hopefully you don't mind, I'm just using the abbreviation for pound, 1 pound is equal to 453.592 grams. And then what's the last thing we have to do? We just say 1,000 grams is equal to 1 kilogram. And then we're pretty much done. So now let's get out the calculator again. Clear that off, and we say 2945 times 453.592, and then divide that by 1,000, and we are left with 1,335.82. So I'll say 1335.83. So we are left with 1335.83. And actually, let me just check that one more time, just because I've been making some mistakes with copying these answers down. So we've got 1335.83, and that is in kilograms now. So now we're pretty much set. We can start putting everything into our de Broglie equation. So we say that our wavelength is going to be equal to Planck's constant. And what is Planck's constant again? Well, it's 6.626 times 10 to the minus 34 joule seconds. And we can actually say, you don't even really need to worry. I shouldn't leave the units off right now, but you don't really particularly need to worry about the units that much. So 6.626 times 10 to the minus 34. And now let's put in our mass. So we've got 1335.83 for our mass. And then what was the number that we got for our velocity? We got 29.952 meters per second. Just change. We got 29.952 meters per second. And one thing that I'm going to do, just to make this a little bit easy, just a tad bit easier to calculate, because this is scientific notation, I can just put these three numbers into the calculator, right? And then I can worry about sticking on the scientific notation later, right, after I'm done. So pretty much what that's going to look like, and I'll just do this real quick, I'll erase that scientific notation, is we're going to take all of this operation, we're going to take 6.626 divided by these two numbers, and then we're going to multiply it times 10 to the minus 34. And that's going to give us our final answer. So actually, let me go ahead and get out the calculator again. So we've got 6.626 divided by 1335.83 divided again by 29.952. And now we're going to multiply this times 10 to the minus 34. But really, it's going to be in scientific notation anyway, so we can just move this decimal place over a little bit more. So we say if 34 is right here, and we say 35, 36, 37, 38. So our final answer is going to be 1.65, or it's actually going to be 1.66 times 10 to the minus 38. And let's actually just check that again. Hopefully you can see what I'm doing. I'm just trying to move, I'm just going through this in my head where I'm moving the decimal place over. And hopefully you've seen at least enough examples in other places in the playlist of me doing stuff like this where you're not too confused by this. But so I'm going to move this decimal place over. We know that this number, so actually let me go ahead and write down, this number came out to 0. I think it was it 3 zeros or was it 4 zeros? Sorry, one sec. Okay, so 3 zeros, 0, 0, 0, 1, 6, 6 was what this number came out to. And actually, let me go over here. So what this evaluated to was 0.000166 times 10 to the minus 34. And so now we want to figure out what would this be? What should we write this as? Well, our decimal point's going to move over to the right 4 spots, right? We've got 1, 2, 3, 4. So we're going to count, we're going to, I guess, decrease this by 4 units. So it's going to be 1.66 times 10 to the minus 38. And we know that what is wavelength measured in? It's measured in meters, right? So this is going to be the wavelength of a car going down the highway at 67 miles per hour. And this would be our final answer for wavelength. So hopefully you found this interesting. And in the next bunch of videos, I'm just going to keep doing more problems. Thanks for watching.